Great. Can you hear me at the back? Okay. Okay, so we'll get started. So tonight I'm going to give a lecture on my work since I was aged about 18 through to today. And Eve asked me to make it the complete works, including all the work that I did in computer games, stuff I've done in business. So normally I'd split this into two talks, but tonight it's going to be one talk, but covering both these topics. So there's going to be quite a lot of art. There's going to be a bit of molecular graphics and a certain amount of computer games. In some ways, it's a journey that covers many different subjects. And these images are from 2014, produced during the last couple of months. Strong references to Surrealism. Some people describe them as slightly psychologically disturbing. Some people describe them as Escher on acid. Someone else described it as the journey to the center of the alien spaceship. And so these works are open to multiple interpretations. And my job as the artist is to work with a team of programmers and define a space of possibilities and then explore that space of possibilities as a gardener. All I'm doing is unraveling what's already there. And all I'm doing with these works is presenting the work, the images and forms that entertain me, that interest me, that I think may have impact. The other key thing about these forms is they're always dynamically changing. So that form, a few seconds later, will have unfolded and blossomed into a strange flower and then folded up again. So the work often references art and nature. That's a kind of recurrent theme throughout the work. Going back in time, this is one of the images I produced around 1990, using the same form grow and mutator code that we've upgraded since then and is part of the new work. So this was produced on an IBM mainframe. It has a very nice CSG modeler that does the rendering. I guess the difference now in my work at that period, I would always have the images. You could see the whole thing. You could see the silhouette. But now I want to be much more up close and personal so that you as the viewer, you're right in the center of these complex 3D forms that are continually dynamically changing. So I'm a professor at Goldsmiths, and I'll talk a little bit more about the work I'm currently doing at Goldsmiths towards the end of the talk. So this is the structure of the talk. It starts in 1979 through the work that I did at the Ruskin School of Drawing. Then I talk about the work I did at the Royal College of Art, then the work at IBM, and then in number 4, where I got heavily sidetracked. I got seduced by the game world of rave music and computer games, and then finally resurfaced in about 2003, and then went finally back into academia, and finally started showing work again in around 2013. So this exhibition is the first exhibition that I've really had of about 20 years of my work. So previously it was shown in Brighton and then greatly expanded, coming here working with Eve, who's been fantastic to work with on this project and has been a catalyst for new work. Then I'm going to talk a little bit about neuroscience, the work I'm doing with UCL, and then also some of the kind of longer-term visions. So it's quite a big span of time, but hopefully we'll kind of get through it and get into more detail. So going back in time to 1979, no mobile phones, no photocopiers, no computers. You know, if you were interested in doing any programming, you'd be doing it in Fortran 77. So I was a student at Oxford University. This is the art school where I was based. And prior to that time, I had worked my way through contemporary art. I'd done paintings like Impressionists, Cubism. I worked through every single art style, spending about a month, maybe 2, on each art style. And was perfectly capable of doing good oil painting. However, there was one turning point where there was a dancer called Arlette Bonn, who at the Museum of Modern Art in Oxford, which is a fantastic big open space, she ran a dance class for artists. And I was extremely skeptical. I nearly didn't turn up. But what was interesting was that she got us moving in patterns and then mapping the choreography of those steps. And that workshop only lasted a few days. But what it resulted in was a series of drawings which used geometric shapes mapped out on a 2D plane. So these were some of the paths that I was designing for dancers. And then these became the basis for abstract films. And then even more complex with that was that I actually started to build in balsa wood using these 3D plans as a way of projecting 3D forms in space. So you imagine this is a dance move that's mapped up in 3 dimensions. And these sculptures were pretty big. This was about 4 feet. And they'd hang like cobwebs. And referencing people like Man Ray, I became more interested in the shadow. Even the shadow of the form had merit. A lot of my friends were chiseling stone and making sculptures out of kind of metal and soldering irons being used liberally, and I was making these very delicate balsa wood structures. And then what I would do is I'd take them and print them in 3D. Ironically, years later, some of these forms have close resemblance to some of the protein structures that we've been working with with Imperial College. But this work was all done pretty much without a computer. I used classic 3D three-point perspective, and these mapped out really the paths that these elements would follow in these animated films, referencing people like Donald Judd, Sol LeWitt. Minimalist art was having a strong period at that time. So some of these drawings kind of reference people like Uccello, but they were all done in 3D. With a compass and a ruler, you can produce a lot. You don't necessarily have to use software to produce interesting images. And then these were some of the forms that we produced at that time. So influences, Russian constructivism was a major influence. Fantastic, definitely the way in Russian constructivism they blend art and design, fashion and design, all mixed up. So it's a continuum. Obviously Tatlin's Tower, Malevich, very strong influences. Obviously Naum Garbo is an influence. But also contemporary music, craft work. At that time, I always thought that people working in music using synthesizers were doing highly innovative work. And at that time I would be doing these strange Boston sculptures, listening continuously to Kraftwerk, Computer World. So, and obviously people like Moholy Nagy was an influence. But also the idea that Joseph Beuys was that you just set up the components and you just let it run. And you don't interfere. So Beuys just put himself in a room with a coyote, and then over a period of days, just whatever was going to happen was going to occur, and you as the artist just let that unfold. And that underlying philosophy has been important with all the work. You have to let accidents become part of the creative process, even if you deliberately introduce randomness into a piece of work. You have to let it be untouched. So it was taught by Kenneth Martin, who's an English painter all his paintings were using constraints, and he'd throw dice to define how the shapes would be mapped onto the canvas. And he was very influential, the idea of using chance manually within an artwork. Eduardo Palozzi was a huge influence. Extremely well-known sculptor, very strong individual, challenged the art world the whole time, and he certainly throughout my career until he died was a big ally and encouraged me always to be doing something that was novel, use technology in novel ways. And these were some of his silkscreen prints from that period, beautifully printed. And he also made sculptures that he would take packaging and then expand them to a large scale. Tim Mara also taught me, and also Mary Kelly, coming back to the idea of a process. She was famous for an exhibition where she displayed babies' nappies on the wall, and it was just a month's worth of nappies. And, you know, again, this idea of just process generating the artwork. So moving forward in time, I then went onto the Royal College of Art. So I was around 21 at this time. You know, a lot of artists would think, well, I've kind of got my art style now cracked. You know, I can keep going and just keep making work in that style. I've always been restless. So at that time at the Royal College of Art, which is based in Kensington Gore, all my friends were doing paintings like Baselitz, Julian Schnabel, very passionate, you know, painting. I was a Henry Moore scholar, so I met Henry Moore several times. What did I learn from Henry Moore? Well, you know, fantastic use of form, but the idea, what struck me when I visited him was that he was chiseling away, and it was, you know, take him hours to chisel some form out of some rock. And the idea is that if you position yourself as a laborer, as an artist, your imagination is going to be trapped. You won't be able to release the full creativity that you have as an artist. So, you know, he was very supportive, encouraging, but all the time I felt, well, I'm not going to be a laborer as an artist. And the whole idea later of using computers was to remove the labor, so that a device does the work. So as a student, I was spending a lot of time in the Natural History Museum in London, which is just down the road, looking at dinosaurs, looking at natural forms, and then started to produce these large evolutionary drawings. So across the top of so these are rule-based. There are a set of geometric primitives across the top, and then using a set of defined transforms, as you move down the page, they become richer and richer as more of these transforms are applied. So, you know, very much influenced by the idea of evolution. I also produced etchings at that time. This form, which is in the room next door, was all evolved from a cone. These were the rules that I defined. On the left-hand side, you have these transforms. You select the scale, so it's like a piece of software. The difference is I was using my brain as the graphics device to imagine what effect these rules would have on what effect they'd have on a form. And so some of these drawings were about 30 feet long. So here you see the geometric primitives. The bulge rules means you have a kind of bulge pulled out the side. Beak means you kind of pull out this triangle. But what was interesting was quite quickly you could produce quite rich sculptural forms. And my friends in the sculpture department were always trying to find novel ways of producing original and interesting forms. And I found just with the system, it was like Pandora's box. You know, it would generate as many interesting structures as you could care for. And this is one of the big drawings I showed in Tokyo, and there's a scaled-down version of it in the exhibition. And as, a bit like evolution, as you move through different parts of the tree, you have different types of forms, sort of strange kind of truncated tree forms, other more kind of architectural forms. So also this work started to make me think about maybe how great human creativity is. Maybe it's not such a mystery. You just got to define the rules and let it go. But that's a kind of recurrent theme that comes back again and again. This was the original flow diagram that I designed. Initially, what I tried to do was, from within the tree, pick forms and actually make them into physical sculptures. And then in the sculpture department, people like Anish Kapoor were there, great sculptors working. But I'd always try and get the technician to produce these for me, do the labor. And then there were more complex rules defining how forms would be joined using location points. So where did this idea come from? Well, fractals were around at that time. The idea of an iterative process being used would create complexity. So the fractal geometry was just emerging at that point, and I'd come across papers that covered that. Conway's Game of Life had been around a long time. Again, what's interesting with Conway's Game of Life, it's a little bit like a kind of a chess game. It maps black squares based on very simple rules, a bit like moving drafts pieces around. But what's interesting is once you set these rules in place, you get gliders and other features emerge. Things would slide across the page, and as a human, you would read them as gliders or pond life, but actually it was just a very, very simple system that was just generating these elements of content by chance. Also at that time, Steiny and March were also, they were convinced that you could take the Froebel building blocks, which are a simple set of cubes, and generate any architectural style from that. So they were convinced you could produce Palladian architecture just using a simple set of rules, and I was taught by them at that time. Another influence was American graffiti art. Keith Haring was showing extensively at that time. Saul Sternberg, American artist, was also an influence. Outsider art, the idea of there was a big exhibition of outsider art at the Hayward, and some of these forms started to become very rich and ornamental, and were influenced definitely by tantric art. Was again the idea of mandalas. The image can be any way up. Definitely, a lot of my work has not referenced necessarily Western art. Tantric art has been a kind of big influence, particularly kind of Shiva-like forms with multiple limbs, and that kind of level of visual richness. Going back in time as a child, I was very interested in Audrey Beardsley. Again, a very, very confident, clean line being used. But also, if you look at Magritte's exquisite corpse drawings, the idea of using a simple system to generate drawings, André Masson's surrealist automatic drawing, but also Paul Clay's idea of taking a line for a walk was also an underlying idea. But also the idea of, you look at medieval, well, it's not medieval, but the idea that the image can just be used to disclose information. This tells the story of the life of the Duke of Upton. The artist just jams everything in as best they can, and the composition is not important. It's just how you get everything into the picture. So that was exactly the same idea when I was doing these drawings. Composition is not a concern. But also the late Picasso, where he is trying to just churn out drawing after drawing, almost challenging himself to see how creative he was. That was, again, an underlying theme that influenced the drawings at that time, and obviously Leonardo's drawings. So quite a lot of references in this talk, but I was taught by Keith Critchlow, who'd worked with Buckminster Fuller on Euclidean geometry and how you create complex 3D forms, using simple rules. John Lansdowne I was doing a PhD by this point that I never quite finished, and he was a very interesting man that he wrote extensive papers. He did a lot of work with the Royal Ballet School, but he also worked on the Alien film using kind of vector graphics, but he encouraged me more and more to get involved with software. So then what we did was we started to switch it around, so instead of using a flow diagram, using a random number generator, it would kick out drawing instructions that I would then draw. I was the drawing device. And again, this was a real revelation in the idea that the computer doesn't have any aesthetic idea, and this would force one to draw things that you would not find aesthetically pleasing. And so these are some of the drawings from that period. Interestingly, even using software now, you can't do certain things, like the marry operation, which the form synth rules allowed. It's still hard to do that with software, how you take two forms and in between them. The human mind is still pretty good at that. A piece of software will just give you a very dull in between. So the work also coincided with Richard Dawkins. The disadvantage with being in the history books, which I kind of am, some books anyway, it's history of art. The work I was doing was absolutely the same time as Richard Dawkins' work, and he came and talked at some of the exhibitions that I did at that time. But Richard Dawkins, again, is very interesting. He's using a pick and breed interface, and within that pick and breed interface, he himself, you'd see things that would look like alien spaceships, other things that looked like aphids. But underlying it were extremely simple rules that had no concept of content. The human viewer would just bring to bear their own interpretation. And then the Blind Watchmaker book came out about that time. So by that time, I'd started to get more and more involved with writing papers, and this was the first conference that I gave a talk at. But by that time, I'd become more aware of what was happening at SIGGRAPH, the advent of photorealism, the work of people like Jim Blinn, Ken Perlin with his fantastic, rich kind of noise texture, but also this idea that if one was going to do interesting work with computers, you really had to be in a laboratory. So, there were no PCs really around at that time that would enable you to do anything interesting. And so, also, what it struck me was that you could actually start to produce things that were photorealistic, a little bit like a Dutch still life painting, using software. So then what happens, following a cold call to IBM, I got talking to a nuclear physicist. He found the work that I was doing really interesting. And I went straight from art school into a corporate environment, where I spent the next 6 years. And at that time, basic philosophy was to take these kind of crazy rules that I'd produced for creating these drawings and transform that into software form. So IBM at that time, the Scientific Centre, had done a huge amount of work with scientific visualization, molecular graphics. So it was a fantastic opportunity because it was like a kind of Renaissance situation. You had mathematicians, archaeologists. There was a surgeon there who modeled a human heart beating for the first time. And we'd all be thrown together in this lab, and I would be there as the artist, and they would put great programmers and mathematicians to work with us, and just to see what would emerge. So I started work with Stephen Todd, and also with Peter Quarrender and John Woodcock. So this was the point where some really substantial collaboration started to emerge. And in particular, it would give me access to huge render farms. And also IBM would fly me around the world, fund exhibitions. At that time, certainly these corporations wanted to produce exciting work that would capture the public eye, and my work, because it was producing very nice visuals, certainly did that on a global basis for IBM. So the slightly younger version of myself, this is us sitting in the lab at IBM, Stephen Todd on the right, and this you can see just from the age of the machines in the background, the types of technology we were using. And in the floor below, there was a big server farm that was just full of computers. Now that would be equivalent probably to 2 or 3 PCs, but then it would be a big operation with cooling units, the lot. But the central idea of the artist as gardener emerged at that time. And so just to quickly go into a bit of technical detail, we had a very nice CSG modeler that had been used for molecular graphics, enabled one to do very nice Boolean operations. You could union forms together or difference them. They had the same set of geometric primitives that I'd used in my drawings, so that was a kind of very good starting point, and had nice marble texture. So these cubes, if you cut them, the texture would go right the way through, like you were cutting a piece of marble. So these were the Boolean operations. But what we did was we built an interface that had a subjective UI. Or you said, well, something's good, bad. You could marry it, breed it, kill it, or set the mutation rate. And so these were the kind of gardening operations that I would be using to generate the forms. So it was a 3-tiered system. We had this renderer at the bottom. We had FormGrow, which handled all the geometry. And then Mutator was the subjective front end that would sit on my screen. The FormGrow code was written in a special language that Stephen had written called ESME, which was primarily used for scientific visualization. So these were the primitives, but what we did was we started to create a new set of grammars. We moved away from the bulge, beak, scoop, and we started to have things like ribs, stack, bend. But quite quickly what we found was that you could produce forms that looked quite natural, like horn of horns would give you forms like this. Horn add horn, so you have an egg form, which was just, again, a stacked horn with this strange horn coming out the side. But some of these forms would start to look more, a little bit like pond life. Some of them were a bit Freudian. Others were very kind of elegant, web-like structures that we then animated and brought. Again, all these things would be dynamic. They'd be dynamically changing. And then we employed a little bit of fractal geometry, so you'd have a horn of horns in a fractal style. We would normally put a cap on the level of recursion, otherwise the machine would just completely crash. So the problem with fractals, it would just keep adding little horns endlessly. And then we had different types of branching. And once you sort of had layered branches, you kind of, and a little bit of bump mapping, you'd start to create these strange types of forms. This was about 1989 that we were doing this work. Again, this was a form that I was very pleased that emerged. Kind of looked a little bit like a squid, but it had these components. Again, they are natural but unnatural at the same time. Also, you could use it to produce very elegant, beautiful forms. Maybe what could be maybe used now as a design of a new iPod or a bit of technology. So it was capable of producing exquisite, elegant, simple forms. They didn't have to be wild and wacky, organic structures. But all the time, if I'm honest, I was kind of looking at the natural world and seeing what geometry we could steal and simplify. And, certainly things like snake skeletons, butterfly eggs. Nature is endlessly rich in its kind of source of inspiration, even things like tapeworm. So drawing was a part of the work, and we wrote a book that included drawing. So when we were designing the software, I would often do drawings or annotations which would then be coded. But in essence, with the mutator code, it's a bit like an evolutionary fruit machine. You define the form as a list of transforms, and you pull the handle on this evolutionary fruit machine, and it kicks out variants. So in the parent is top center. All the ones around it are variants pulled as a result of using this evolutionary fruit machine. In this instance, the rate of mutation is quite narrow, quite small, so they're quite closely related to the parent. This was the first version that we did using a RISC 6000 machine. And so you can see one generation with two sets. These are ammonite-type forms. But in effect, what you're doing, if you've got a structure, maybe it's got 100 parameters, that's a highly multi-dimensional parameter space. And so as soon as you create the structure, but implicitly all these forms exist out there, and by using an evolutionary interface, it enables you to navigate this multi-dimensional parameter space and hone in on the forms that you're interested in. You could crossbreed forms, 3 types of marriage, a bit like in real life. So there was arranged, random, and grouped, and there were no limits to the number of parents that could be involved in crossbreeding. And in general, you had 9 offspring. This was what we coded up, and that in terms of navigating that multi-dimensional parameter space, as you'd be breeding, you'd find a form that you liked, might look like a kind of strange ancient squid crossed with an alien spaceship, and you put that one to one side and say, well, I'll breed that back in later, and you keep exploring, find something interesting, and then take the one that you've saved maybe an hour earlier and then crossbreed them. So it's a kind of completely unorthodox way of working as an artist. But the richness of form in that space is fantastic. What's interesting about navigating that space is that you have periods of time when there's nothing of any interest. It's like a desert, and then suddenly you find a rich vein of forms, and everything is interesting. Something that Carl Sims also referred to later independently. What's interesting is that the computer starts to become like a creative partner. Your ideas as an artist about form structure start to become embodied in the software. And what you're doing as an artist, you're bouncing off that structure and that generative energy that kicks the variants out, you choose them, and then breed again. So these are some of the forms that we produced at that time. So we did quite a bit of work on structure mutation. We never got it perfectly working. In effect, what that means is you're randomly inserting transforms into the structure so that the structures could then become extremely long as these transforms were added. Conversely, you could pull transforms out of the stack automatically as well. The reason why we found it quite hard to get polished was if you've got one form that's got, say, 1,000 parameters, another one's got 40, it's quite hard to crossbreed them because you've got to work out where all the numbers go. So Carl Sims, with his approach using Lisp, he was able to do a much cleaner form of structure mutation. So Carl Sims and I were working exactly the same time, extremely exciting period at SIGGRAPH. So by this time, SIGGRAPH had become a very dominant festival, computer graphics festival. And Carl's system, which primarily came out of his interest in image processing, used a similar type of interface. So he, like us by that time, had looked more closely at the Dawkins system, and both of us had stolen ideas from Dawkins at that time. But again, Carl commented that once you start using these systems, content emerges. The human eye picks it up. It'll spot human faces. It'll spot all sorts of content. A bit like looking at clouds. Content comes for free. So this was a show that he did at the Pompidou Centre. So at that time, to do anything interesting, you really had to be sponsored by a company. So Carl was sponsored by Thinking Machines. Kawaguchi in Japan was sponsored by Nippon Electronics. So a very, very different landscape there. There were very few computer artists. Now thousands of people are using Unity, using modeling packages. At that time, you were kind of a rare species. And so the great thing about SIGGRAPH was it was quite competitive. Each year we'd try and write new algorithms, produce new films, and go and show them at SIGGRAPH to this kind of growing audience. So in essence, what I was doing was evolution by aesthetics. So I was the cost factor, if you like, deciding whether something survived or died or was going to be rebred from. That was the kind of central idea. These were some of the forms that I evolved at that time. This one had quite a high rate of mutation. If you cranked up the mutation rate, certainly you'd start to get some quite bizarre forms. And these forms were completely 3D. You could spin them around, mutate them again. They'd dynamically change into a new variant. So in many ways, these were a little bit like the ink blot test. As I keep on mentioning, the viewer interprets the content. And from my point of view, it was like exploring a kind of psychological landscape. So when I was breeding forms, anything that looked a little bit rococo, I would always keep. This was kind of my aesthetic. Anything that looked a bit like H.R. Geiger, unfortunately died very recently. I loved his work. Anything that had a Geiger-esque element, I would breed from. Paisley patterns, anything that looked like Greek Roman helmets. In fact, I've been looking recently at photographs of drones. Those fantastic, beautiful forms. Again, putting aside their function aside, definitely that would be a criteria for breeding from. Anything looked like pumpkins. So every October I'd find myself breeding forms that looked like pumpkins because it was getting near to Halloween. Also, ironically, they quite often look like viruses as well, the same time. Plants, fantastic in the world of plants. Look at zoom in. Some of these forms look like some of the new forms I've been creating. Fantastic richness, kind of casual symmetry. You've got things symmetrical but not perfect. Orchids, pond life. Insects, there's pretty savage content out there. If something looked like this, I would often save it. But also heavy metal imagery, anything that looked a little bit, wacky, Megadeth, I'd save it. Actually, heavy metal bands are great at names, actually. So, but that it was all part of my kind of aesthetic repertoire, if you like, my kind of profile for picking forms to breed from. At that time, I had some discussions with Mandelbrot at Yorktown Heights, who I was lucky to visit, and he raised this question about how do you replace the human artist with a machine to do this automatically. And he recommended that a fractal filter could be extremely useful because it would pick up on the golden section. The Parthenon is very successful in the terms that it has big chunky detail, a certain amount of medium-sized detail, and lots of little detail. So his idea was that as a pre-filter before I would make my selection, this thing would prune out all the rubbish ones. Again, this is something we're finally working on again now, again, 20-odd years again, how you replace the artist completely so the machine does everything. So, a bit like the artworks here, running on the screen, it will run for 100 years, 1,000 years. May even produce more interesting forms than the artist. I guess the challenge is how you program all that crazy stuff like heavy metal and stuff that I am using when I'm interpreting the forms. There's quite a lot of cultural content you've got to capture in software. So maybe the artist isn't quite dead yet, but our brains are just like very fast computers designed for visual activity. We're just extremely fine-tuned for a particular specific role. So I guess in the work, what I'm trying to do is narrow what the human does to what the human does best, but ultimately the aim is to replace even the human within this system. Also, so IBM weren't sponsoring me just for fun. They were obviously interested in what patents emerge. So working with Stephen, we produced a system that could be used for generating architectural designs. I don't think I have got time to run it right now, but after the talk I'll show you the software running on this machine. So the idea was that you're an architect, you've got the building top left. This is just in 2D. You've run out of ideas. You hit the breed button, and it generates variants quite quickly. You crank up the mutation rate, and you start to get pretty interesting contemporary buildings. And the idea was that the software would be like a creative brainstorming tool. But also the idea was that you didn't have to be an architect to design buildings. The public could take part. You could also build in constraints. So the size of the roofs have to be large enough for solar panels. I don't think there were solar panels around when we were doing it, but the idea is you could have constraints. But also quite quickly you can produce things that look like Frank Lloyd Wright. So I showed this at the RIBA to a distinguished company of architects and told them they'd all be out of jobs, and I never got invited back ever again. Particularly when I reminded them that architecture is an evolution. So again, what we were doing was applying this to a different problem domain. So the idea of automatic culling, you can set constraints up that prune out your variants that you're generating. So here we did a little bit of work designing little robot figures. Maybe future of genetics, who knows? But also, like if you look at something like a Chanel perfume bottle, or you could just generate variants. So what we were doing here was we were mutating the spline points to generate different designs. But we also did a lot of work using mutation techniques and spreadsheets to predict profit and losses for company models. So this was some of the kind of research that IBM was more interested in. We connected this up to Lotus 123. So again, the idea of if you're running a company, you can't always anticipate what's going to happen next. But with this, you could explore different ways of predicting the future. And what you found was that quite unexpected combinations would give you a huge profit, but also unexpected combination of numbers would give you huge losses. And so this was a kind of a prediction tool for business. So as I mentioned, SIGGRAPH was a great catalyst. SIGGRAPH was great in some ways, but it had a disadvantage in that the art world would always just view computer art as computer graphics. It would kind of be lumped together. It was always viewed as not art. So in the long run, I would say SIGGRAPH hasn't helped computer art. So Scientific American were kind of writing about us. We wrote a book, but there were lots of great books written around that time. L systems were emerging. And then I had these exhibitions that would tour. So this exhibition was touring for about 2 years. Interestingly, I went to the Natural History Museum where I'd been originally inspired. And they went to the archive and brought out lots of artworks like armadillos and these strange skeletons and put them next to the images. So that was very nice. And then I had this exhibition in Tokyo that ended up touring to Australia. Context of art, okay, so return to Renaissance art. Definitely this was a return to that Renaissance environment. The idea of Dutch still life painting being rendered, so this is one of my rendered forms. It's got reflections, cast shadows. And I would raid lighting models, like Rembrandt lighting, I would apply to some of these forms. Obviously, there's references to Max Ernst, heavy use of texture, the idea of... So what's interesting about the Surrealists was that they would use random techniques to get their paintings going. Max Ernst would use rubbings as a way of suggesting what content would emerge out of the picture. Again, it's a similar approach. I'm just using a random number generator to find that content. Another very interesting artist is George van Tongelu, where all his sculptures are equations. It is art as an equation, which in effect these three-dimensional organic forms are. They are, you could boil them down to a mathematical equation. At that time I also met Matter. We met in Monte Carlo at the Imaginer conference. We were on the same panel. I've been always a huge fan of his work. Absolutely brilliant painter. This is one of his large-scale paintings. So he would start a painting by throwing a bucket of paint at the canvas. So we planned a collaboration that never quite emerged, but he definitely really liked my organic forms at that time. So art. So, I think, ready-made art with Jeff Koons, Marcel Duchamp. It's a kind of cheap trick that's kind of run its course. With computer art, you have the ready-made in the form of the computer, but the computer only becomes a vehicle to generate the content. So my work uses a ready-made, but it's purely a launch pad, just to present a vacuum cleaner and stick it in a cabinet. The novelty is going to wear off pretty quickly. So the challenge with the art world is that if you've got a system that can produce 1 million variants of that, it's a little bit hard to sell 1 million variants. So again, I guess as I come back into the art world, come back into the fold, if you like now, I'm thinking a little bit more how I deal with that issue. And my selection of key works becomes very important in that scenario. But intellectually, there's no point doing white paintings or just recycling contemporary art. Contemporary art, to me, seems like it's reached a complete dead end. It's just endlessly recycling of what other artists have done. So what happened next? Well, I had a choice. IBM had been hit by the 98, 99, 89 recession. So it finally caught up with IBM, and they closed all their scientific centers down. Now, I got pretty comfortable there. I was having a great time working with a fantastic team of programmers. And by that point, my imagery had been extensively used in rave culture to take ecstasy watching. So I hadn't realized, whilst I was locked away in this corporation, everyone was out there having a great time watching my films taking ecstasy. And, I thought, where's my audience? The art world has always been a bit uncomfortable with me, still probably are. But this was my audience, the kind of mass kind of culture. So I then had a decision. Do I go back into academia, put on my art hat again and, be a serious artist and be intellectual, or do I plunge myself into this culture? And computer games was just kicking off at this point. There was technology, entertainment had started to marry up. So, which decision did I make? Well, I decided to go into, popular culture. And then I found myself the next 10 years working in this particular space. What I'd done was I crossed the line between art and entertainment. And those of you who are considering this, don't underestimate the difference between life on both parts of that diagram. Nice thing about entertainment, if it's something it's very measurable. If it has impact, excitement, if it sells, it's good. In the art world, some critics got to like it. Then you get a few brownie points. Again, the Shaman had become big fans of my work, and they'd got into a lot of trouble for advocating the use of ecstasy on BBC Top of the Pops. And Colin from the Shaman, I probably cut this bit from the recording, he'd taken a lot of drugs from the Amazonian rainforest. And there was one particular drug that he took that had been provided to him by some Indians, and he always saw my forms whenever he took this particular psychedelic drug. So they then approached me to become their artist for the next 3 years, producing all their album covers and directing videos, the lot. What I did, whilst I was still at IBM, working with a very good programmer called Chris Jones, we quietly over a weekend found out how we could hook up the entire IBM network to render their next video. They'd give me a handsome check to do it. So already I was starting to do commercial work even at the tail end of IBM. So I moved to Soho, set up a small company in an attic, very different from the kind of corporate environment that I'd been in. These were some of the album covers we produced. So, people ask me, why did you sell your soul? Well, it was fun. It was interesting. It was entertaining. You didn't know quite what was going to happen next. I ended up shooting videos, directing dancers. Kind of crazy. But what then started to happen was we were approached by Warner Brothers to produce an app using this imagery. So the only challenge is this was 20 years old. We got it running on an IBM 486, or maybe a little bit more powerful. This was hugely popular. Everyone would have it running. It was a kind of exotic screensaver. You could design these little scenes, and then these scenes would run endlessly. And people would stop me in the street and shake my hand. William, really love organic art. People that ran garages. All sorts of different people would have this running on their machines. And what people could do is using these different components, they could pick and breed and generate variants of their like. So people would. I remember one couple had fallen out. The girlfriend had got the dog, and they said the only thing we've still got in common is organic art. Will you produce a special shape that I can create a scene to give to my ex-girlfriend to try and get her back? So it was interesting the way people were using your product in the ways that you would never have anticipated. We also produced a game called Evolver, which was a kind of genetic engineering game, 20 years earlier than Will Wright's Spore game. Interestingly, he hit the same problems that we did. If you start mutating stuff that looks too wacky, the general public don't like it too much. So we were sort of constrained by how mutated these humans could become. The problem at this point was that if you're working for a large publisher like Virgin, they want lots of death in your game, killing and things of that sort. So quite quickly you realize if you go into the game space, the other criteria at work. So we did different things like Robert Miles' Children single, which was a big hit. But by that point, Universal, I was rung up by a producer from Universal who knew a lot about my IBM imagery and the organic look that I'd produced. And they said, well, it'd be really cool if you could do a sequel to the film The Thing, which is a John Carpenter film set in Antarctica. It has this bizarre alien that sprouts legs. It's absolutely horrendous. Why don't you take your style and apply that to this game? So we spent the next year and a half making a hit game, working with Universal Studios. And this was some of the concept art we produced. So I guess by this point, 10 years had run out. I'd become quite experienced. I'd negotiate a $5 million deal, negotiate royalties, had about 70 people working for me. And then I suddenly realized at that point I'd become a little bit bored. It took 10 years to learn that working in entertainment is not that fulfilling. But I guess I wasn't bored. Then what I did was I created another company that just did business. Eve wanted me to include all this, so you're getting the full works tonight. And I would do due diligence on companies. But I was always brought. So what would happen is you'd have international film guarantors would bond big computer games. There'd be about $6-7 million each. In fact, even more. Some were about $15 million. And you'd have a team of creatives, and they would start to do their own thing, and they would start to miss milestones. And I would be brought in as a kind of poacher turned gamekeeper because I was creative. I knew what all the tricks would be that they would be doing, and I would be brought in to challenge that creative team who were going kind of off-piste. Because I had been a creative person myself, I knew how to challenge them and get them back in line. So I ran this company for about 2 years, still exists, working with investors. I'd learned enough about business to operate completely in this field, and you'd be brought into companies to close them down, and everyone hated you, but it was interesting. And so this was some of the financial models that we'd got involved with. So I became a little bit mean to creative people at this time. I would certainly work out what they were up to. And creative people find it very hard to make decisions sometimes. So often all you were there to do was just force decisions to be made. So finally, in 2007, I became professor at Goldsmiths. I'd done 2 years at Leeds before, and Professor Frederic Leymarie had been a huge ally, got me a professorship there. So finally, I found myself back in a kind of creative environment. So the challenge is, a bit like reforming a rock band that died in the 70s. What do you do next? Do you do the same thing or do you try something new? Well, what happened was that the structural bioinformatics group at Imperial College, we met at an event in Imperial, and Lawrence Kelly, who's on the left, had posters of mine from IBM on his wall as a student. He was a huge fan of my work. And he said, well, by the way, William, these strange rib structures you've done with branching and things, they're pretty similar to protein structures. You're showing paddle-like forms. Why don't we start collaborating and see what can emerge from, again, that art-science collaboration? He also mentioned that statistics, which had been used extensively in this space, had started to not yield great results. So there was an appetite for innovation. So Stephen Todd came back. He'd taken early retirement from IBM, so I was able to restart my collaboration with him. Frederic Leymarie, we had a very bright PhD student called Nikki Shaw, and Ben Jeffries, who was very good at physics, was working on the team. So again, this particular space with protein structures, the beta barrel form that Lawrence Kelly, absolutely loved, had, definitely there were similarities in the way that our forms were structured. So I'm just conscious of time at this point. In essence, what we then did was we resurrected the code, re-implemented it in Java. Stephen was back working full out on this. We had to, because the problem with technology, the code dies and you have to re-implement it. And the idea was, in the real world, you have this mapping between codons, amino acids, proteins, and and there's this big mystery here. In our system, we have the complete map. And the idea was that we would try and bring these together and see what some similarities could emerge. So it was a very playful approach. Again, there was equivalence between the systems that they were using and the systems we were using. So in effect, what we started to do was take codon data, we used the same grammar that we'd used for our mutator forms, but converted their codon data using a lookup table to generate code sequences. So this was the lookup table that we used. We did another variant where we randomly generated variants which yielded good results. And then we had to use another lookup table that would generate numbers. And then literally what we would do is we would strip in the codon data and it would kick out Java code, which would in turn generate mutator type imagery. And so, so hemoglobin looked like this. Human insulin. So it was like a visualization tool for taking their sea of numbers and actually creating a visualization that may pick up some of the subtleties within the numbers that they were handling. And so we wrote a batch process. We had this idea of junk code where it would stop reading data and then wake up again. And so it was mouse hemoglobin, mouse keratin. So it was trying to bring nature and art together. I was interested in the artistic side, and they were interested in the scientific visualization side, whether they could use this as a tool for looking at their data in a different way. And the sickle cell mutation has a particular number sequence, and we were actually able to pick that up in our visualizations. If you're interested, there's a complete paper on this that we published. But, a bit like the original forms, you could interpolate between one point in parameter space and another, so you could go from mouse to human, traversing this multi-dimensional parameter space. We then moved on. That work yielded interesting results. We then, more recent work has been specifically around docking, protein docking, and these are just some of the drawings that we do. So it's very interesting, even in this environment, we're still doing these kind of crazy creative drawings. We've done some work taking the mutator code and plugging it into, again, working with Imperial, a mathematician called Tom Coates, to explore a mapping of equations. And then we won a 1.6 million grant to produce a game that has, it's called Docket, which was based on the original mutator approach. We also then finally produced some 3D buildings. So what we did was we took Revit, which is a very nice architectural package, plugged in the old mutator code, and then whacked out some new buildings, perhaps for another visit to the RIBA to bait them a little bit. Again, some great buildings emerge. You don't have to be that creative. Anyone can be creative using these systems. So the butterfly means you drop the butterfly on the one you want to breed from. The little babies in romper suits means breed. You hit that button, it breeds variants. And the skull and crossbones means you kill the ones you don't like. So moving on, gosh, I've been talking for quite a long time. This is some more recent work, working with a neuroscience group at UCL. So I guess having been in business, you always can't resist starting another company. So there's a side company to all my university work and all the protein work. I also co-run the MSc Games course, and I have postgraduate students and PhD students. So with SOFV, which I formed with Brigitte Zix, we are working with cognitive neuroscience groups on little tablet games for post-stroke learning, for forming words or number sequences. I'm including this because you've wanted me to include everything. But what's interesting, if I'm honest, is working with the neuroscientists. The projects are pretty straightforward, but actually it's the revelations that they, if we're going to try and automate that selection where the machine is making the choices, by working with neuroscience, I'm going to get the insights to work out how that would probably work. So this is a particular game with number sequencing, with children with particular disorders. The idea is we produce a Candy Crush type game for number training. And the aim is that this is so the patient can play with their grandchildren or whatever. So it's a community task, not just a therapy in a kind of dry clinical sense. And this is another project where we're working, trying to produce a little app that will enable people with this particular medical condition who can't actually read anything unless it's stripped across in a simple line. So I think, in essence, why am I doing this? Well, I've always tried to place myself where the most interesting work is happening, wherever that is, be it in art, biology. I don't really care. Wherever there's something interesting happening, I want to be right at that point. And the art that's produced is just accidental. That's kind of byproduct. So, fantastic, opportunities showing again. I guess, I finally got quite excited about art again. The art world seems more receptive to media art, not just video art or Nam June Paik type art, or Bruce Nauman type videos, which kind of novelty always wears out. So, showing here has been a fantastic catalyst, working, producing new large-scale works. So I've started drawing again in the retro form synth style, using the same rules. So I actually had to learn to draw again, which was quite interesting, using exactly the same set of rules. And then here at iMAL, we ran a workshop where we used those same rules, and I got everyone here producing large evolutionary drawing across the back, and I got them inventing new rules. So the idea here is that we're all drawing machines using my set of rules. So, we've developed a lot more code. Physics, self-intersecting forms still remains a bit of a challenge. Ironically, it's a challenge also in bioinformatics. So what's the underlying theme here? Why do I plunge myself into a lab with bioinformatics experts? Well, my gut feeling is we're probably going to redesign nature. So this is Capability Brown, 1716 to 1783. Every tree in this scene was deliberately positioned there based on a drawing. This is not nature just accidentally doing its thing. It's a more perfect form of nature, and certainly we have a pretty clear idea why that's appealing. So the idea is that as you start to redesign nature, get involved with bioinformatics, aesthetic decisions will start to emerge. And interestingly, even in the bioinformatics space, there's a gut feeling that aesthetics can help them navigate the space of possibilities. So the idea here is that as the artist, getting right into the laboratory, you're maybe in a position to help in the redesign of nature that's going to happen at some point. Okay, that's the end.
So if there is a question, there is a mic here. So no.
So you got leave to get.
So I
have to answer any question at all within reason.
There is one.
University College London. So in London, Imperial and UCL, as you probably know, are the main competitors. Sorry? No, it may. Certainly in the UK, Imperial and UCL are starting to challenge Oxford and Cambridge as the lead universities. So it's an interesting dynamic.
My question should be in your process that you reach now. What is the most interesting part, the scientific part or the artistic part? What do you think?
It's quite hard because my week is divided up into one-day chunks. So I spend one day on the protein work, working with Imperial. There's a doctoral centre that I'm working on. I think the research and showing art is probably what's interesting me most at the moment. I'm certainly finding now I've got students that then want to pick up my ideas and produce new code. So I can see, finally worked out how universities can work. I'd say I'm really enjoying showing art again, actually, in a peculiar way. And there's a kind of resurgence of interest in my work. I feel like a little bit like reclaiming my crown. I've been out of... I was very well known as an artist, probably one of the best known computer artists in the world with Kawaguchi and people. And then I just got sidetracked. So I feel like, what the hell, I should get that back. Maybe that's a little bit egotistical. I'm enjoying showing work again. I must admit that I'm getting quite a kick finding these forms, and, they're entertaining, they're psychological. I guess I'm quite enjoying university life. I enjoy being back in that situation where research and art are kind of tied up together.
Thank you very much. May I ask you, will you one day maybe work on ethics?
Ethics?
Ethics or anti-fragility or compassion, empathy, and see what comes out of it?
Okay, that's a very good question. So ethics. So that's an interesting topic. I think certainly, as soon as I created a system which had evolution based on aesthetics, the ethics question comes up. But the challenge is that art is a metaphor. It's a counterbalance to what's happening. So quite a lot of my work has said, your work is about genetic engineering. It's about the dangers of if you create a system and start messing around with it, will you be able to control it? It's a very good question. I guess the problem is if you're just working with pure form, which is what I'm interested in, you deliberately put those kind of emotive things to one side. It's like a purely intellectual thing. And it's a bit like the Greek philosophers debating about the elements. It's quite pure. But it's a good question. Certainly, as one starts to get involved more with bioinformatics and things like that, ethics starts to come up. In a university context, you say, well, the ethics committee at Imperial College or Goldsmiths will, I'm sure, comment on anything if it is not ethically correct. Some people say the work is quite cold. It is impersonal. But I've never been a sentimental artist. But yeah, I must admit, occasionally ethics does come up. When I was at IBM, I was rung up by someone who was involved with missile guidance, and they said, well, could we use your mutator code to improve our missile guidance system? And about 2 weeks later, I had a call from a geneticist who'd seen our mutating humans and said, well, can we have a look at your code and see if we can apply that in the kind of embryology space? So I guess the challenge seems to me more is as soon as you produce software, that can actually be repurposed in other disciplines. As soon as you create an algorithm, it can be used for anything, not just producing art. But I think the role of an artist is to have impact and create debate. So I would say that as soon as I have a system that is based on evolution by aesthetics, that is a catalyst for serious discussion around that area. To me, a lot of artists never go near bioinformatics. They're always just, doing ready-mades or, by getting as close to that topic as possible, maybe you raise the debate. You instead of it being like a black art, which is hidden from people, you kind of expose some of the logic. But no, I think that's a very, very good question. I don't know, maybe when I'm 70, maybe I have a bit of compassion. But I haven't probably answered your question properly. But it's a good question to ask.
Well, at the end, you have these ideas while redesigning nature. Indeed, if we go further in this idea, well, question of ethics will come.
Yes,
will emerge.
So I think it will emerge, but my job is not to second guess what those ethics would be. But I think the big problem, to answer your question, is that if you have science that remains a black art, a mystery, then people just really don't understand what it's about. If you can create art which kind of takes some of those ideas and wraps them up in the form of art, maybe the public can engage with that topic.
You said at some point, or perhaps I misunderstood, but that when going back into the art circuits, you were in a way forced to select, or that the selection aspect suddenly reappeared, or something like that. And in fact, you do here. I guess the choice of the works that are shown here is partly from you, at least partly from you. So how do you deal with that? I mean, because that was a very interesting point, I think, between this going on, mutating, always evolving kind of work, and the fact that you, in a way, have to stop it when you decide to show it.
Yeah. I'm realizing that I've got quite a good aesthetic. If you look at other computer artists who are making work, they kind of use fractals, and it's all a little bit tame. My imagery has a little bit of an edge to it. It's a bit uncomfortable, makes people uncomfortable, reminds them of bacteria. Also, everything that everyone kind of wants to forget about, cancer. So there is this kind of edge to the work. So I'm realizing, coming back to the fresh, that when I find a form, I will immediately know that's absolutely the right one to grab. It's a bit like being a wildlife photographer. You've got this thing, you want to grab it, take a photo, capture the data. But yeah, maybe I play that down. But I think even within the mutator code, my ideas as an artist are implicit in the way the forms are structured. So you're like God kind of setting up the world, and then you're like the gardener working within it. So I fulfill both those roles. But in a gallery situation, you can make it that the public can also be like the gardeners. Like the role of the artist and the public becomes a little bit more blurred. I think for me to operate again in the art world, which I really want to do, I'm going to have to play up that selection aspect, that things are not just randomly picked out of a vast space. They are deliberately selected and captured. But yeah, as I come back into the art world, I'm having to re-engage all the stuff that I'd forgotten about before, like, trying to get a price attached to my drawings and things like that. But actually, the V&A have taken a whole set of works. I'm quite pleased about
that. When I look at your work, I feel like I'm staring at some creature that's evolving. And so I was wondering, when you look back at what you've done through all those years, do you see experiments, tries of yours and things that you've made, or do you see creatures that are born from what you've made, so living things, I mean?
Okay,
and
so
not simply art and experiment.
Yeah, I have quite strong sense of ownership. Working in this space, you can sometimes forget that you created something. So Stephen came across this form, and I said, that's someone's read the book and re-implemented the code. That's the other thing that happens when you write software. People will rewrite it and expand it. And he said, no, you did that in 1992. You've just forgotten. So because you can be producing these things quite quickly, your sense of ownership, it can be a little bit lighter at times. And I look at my work, I'm a little bit frustrated. There are things that we haven't done yet, like physics, non-intersection, or partial intersection. That's what I'm interested in, not complete non-intersection. And so that's a problem that we discussed about 1989, how we would implement that. So when I look at my work, I think of the things that we could have done by now, like the automatic selection of forms, where you're bordering on AI. That's a really interesting space. Yeah, so I guess I'm always interested in what I do next. And also one of the key things, I work in a team. The drawings are mine, but actually when we're producing software, it's Stephen Todd, Peter Todd, Frederic Leymarie. So that's been the big shift. We're working with Imperial College. I'm a team member. But yeah, there's things that we'd really like to do that we haven't so far.
Thank you.
Good question.
When you sleep, do you dream of life forms?
What do I dream of? Well, my last dream was being in Korea with everyone telling me how brilliant I was. That was my last dream. I won't tell you what else happened in that dream. But sometimes, yeah, sometimes. Yeah, sometimes you see them.
It's not a nightmare.
I tend not to dream about them, if I'm honest. I'm quite comfortable with them. They're my own creations, so I'm quite at ease with them. They're mine. So I find it interesting if I produce a form that's a little bit nightmarish. I know people can find that uncomfortable. What's interesting, people either absolutely hate my work or love it. There's just one or the other. Never anyone in the middle. So I tend not to dream about them. But I can sometimes be at the machine late in the early hours. That's the problem working in this space. It's quite addictive. You're interested in what you're going to find next.
I know you as I'm trying to find new forms, and so with a reflection about art history, we have new tools to find new forms, and now we have to think through machines, through computers, and through software.
Yep.
So we have to manage about forms created by mathematics. So there is a new kind of beauty, that's the calculated beauty. And I think there is a shift now between what was produced by hand and what is produced by automatic machines like computer. So there is a new kind of morphosis, creating the process of creating forms.
Yes.
But we have to think about semiosis, about sense too. So there is two polarity in an artistic research. We have to, and this is it's a special era in history, because this is the shift between before and after the computer. And what do you think about your research? Are purely formal, aesthetic, or you have to, and do you search about sense to semiosis?
Okay. So you're definitely with wearable devices, Oculus Rift, the forms of human-machine interaction are becoming richer and richer. And I definitely agree that the aesthetics around people are using computers so much that they kind of understand the aesthetic that I deal with, whereas in 1987 people just didn't really understand it. It was people just not using computers. I think what's going to dawn on everyone is that computers will only do so much. Like AI is still a holy grail. No one has cracked AI. You got, as I mentioned before, use of statistics, Google search engines. You've got a limited set of tools that are being used extensively. But at the point where you want to turn to the machine and ask it a really hard question, and it interacts with you intelligently, the machine is just nowhere near doing that. So I think there'll be a kickback, since everyone's kind of enjoying using technology so much, but there'll be a point where they realize, well, actually, it's not quite going the next step. So I think definitely there's aesthetic. I personally think if you're a computer artist, things like Photoshop and things like that. I think to do computer art, you have to be involved with writing code from scratch, whether you write it yourself or you're designing it. I think a lot of those tools make things look exactly the same. They use the same renderers. I think the artist's ideas have to be implicit, actually, in the low-level software to be a work of art. But I think that's a good question. I guess that the work I'm doing with UCL with the neuroscience space is kind of around that area. How you can help patients with neurological conditions through the use of software. So that's kind of giving me an insight into that space. So I haven't quite answered your question, but that's the best I can do.
Yes, it's a heavy question. Have you ever worked with fluid mechanics to do your art? Fluid mechanics.
Fluid mechanics. A bit. We've just taken on a very good programmer to working on the Imperial project who has done a lot of work with fluid mechanics. So yes, the to a limited extent, that would be one of the logical things to introduce into our work, definitely. The idea of physics, these being flexible, non-rigid bodies. Definitely, that's one of the things we talk about a lot, about how we introduce that element. I think would add an extra level of richness and probably, providing you can't see the polygons. That's the problem. If you start bending things around, things become very stringy. They look kind of a bit odd. So one would have to probably bump up the detail to keep the things looking 3D. But if you look like a jellyfish, there's a whole load of physics that we're not using in our work. To answer the earlier question, what's missing is physics. Physics and AI are probably the things that are missing, in fluid dynamics because it comes under that umbrella. But that's very, very relevant. That would be the kind of next stage. Try and get that plugged in. So Peter's just highlighted we are doing some fluid mechanics in the Fold Synth and Imperial project. Okay, so any final questions?
Alan, come to the mic.
I find that with your drawings, you transmit a lot of information.
Yeah.
And it's for me. I mentioned to you earlier. It's like a learning process standing in front of a drawing.
Yeah.
The other stuff, well, whatever. Do you think that it is possible that you are? No. That's not the question. The question is, do you discover algorithms or do you create algorithms? And then, just to take it one step farther, because there was a question here. What's that?
Okay, that's a good question. So we're using a lot of algorithms plugged together in algorithms all over the place. Some of those we'll get from published papers. There's lots of well-known algorithms around. The mutator interface with the navigation in multi-dimensional parameter space, so it actually starts to learn what the user is, which vector direction they want to take. Probably is a novel algorithm. I would say it's a mix. It's a mixture. I think what we've done is we've pulled together a lot of algorithms and plugged them together in a novel way.
Are we writing code or are we discovering code?
As soon as you have a mathematical language, I guess all algorithms are implicit. It's how, you know, it's, a mixture. You know, maybe there's a great algorithm that we still need to produce. Yeah. So I guess it's a collage of algorithms. You know, I think probably the work with AI will generate probably a novel algorithm, is my sense. I guess one of the challenges, like, to answer your question, a lot of people, you know, some people say to me, probably 10%, you know, why didn't you just keep drawing, William? We love your drawings, you know. But that's not enough. I think these forms, these 3D forms, looming out of computer space. But you know, if you look at, you know, any scientist, they probably only produce a handful of original algorithms in their lives. But that, you know, it's a good question. I guess we're assembling different algorithms, plugging them together. Okay.
Okay. Thanks a lot. Let's have a drink.